so let's take a look at that page 65, if you don't mind. Questions on any of those odds? Yeah. 7, you got it. So we can go ahead and do the negative b over 2a, no problem. But I think this one's going to factor, and we're going to start factoring it, okay? And 2, 6, 10, good, yeah. All right, so it'll open down because it's negative out front, but I'll factor, so I'm going to multiply those together. So I'm going to get myself well, it's a negative 14 actually, or a positive 14. So let's see. So I'm going to go that way with it. No, I'm not going to go that way with it. I'm going to go ahead and do my, why am I doing this? It's acting like it's my first time in class. Negative 2x squared minus 12x minus 7. All right. Insert math graph Cartesian. Move you on over a smidge and move down. Okay. Let's do negative b over 2a. I mean, this one might have factored out, but I don't like having that negative out front. So I'm going to go x equals negative b over 2a, which is negative 12 over 2 times negative 2, which gives me 12 over negative 4. Is that okay so far? And that reduces to negative 3. So that's my axis of symmetry. So negative 3. Cool. How do I get the rest of my vertex? Plug it in. Good. All right, so if I take negative 3, plug it in here, that becomes 9. 9 times negative 2 is negative 18. Then negative 3 times negative 12 is positive 36 minus 7. Is that math okay? So negative 18 added to 36 is positive 18, right? Positive 18 minus 7 is 11. Ew. All right, so that means I'm going to have to adjust this a little bit. Nope, wrong way. All right, ew, okay. At least I have to change my asymptote now. My asymptote was negative 3. And then I'm going to go negative 3, positive 11, which is about right there. Those are counted by 2s. And then it's 135 is not going to be 135. We have a negative a value, right? So that's going to be multiplied times negative 2, so I get negative 2, negative 6, negative 10. And that indicates it's going to open downward because we did that. So from here, I'm going to go right 1, down 1, 2, left 1, down 2. Might be able to find some roots, but I don't know. From there, I'm going to go right 1 and down 6. 1, 2, 3, 4, 5, 6. I go down now? Yeah. There. Then I guess I could go down 10 as well. Right 1 down 10. Right 1 down 10. So I'm getting to negative 7 and negative 7. Ooh. So it definitely crosses the x-axis, right? Pattern graphing didn't kind of lead us to the problem. So did we answer everything on this question? It says graph the following, 1 through 5, label 4 key points. Got it, vertex, roots. The roots, though, happen somewhere in there. I don't know the exact value of it because the pattern graphing didn't reveal it. We might come across other methods that might show us those a little easier later. What other questions might you have had on that worksheet? 5? Ooh, the 1/2. Thanks for asking around that one. That's a good one. It's a good one. All right, number 5. Ooh, okay. Got a 1/2 out front. Oh. Okay, well let's, Hey, 1/2 is the same as what decimal? 0.5, okay. So maybe we should refer to that as 0.5 when we plug it into negative b over 2a. So I have negative b over 2a. That's what x is equal to. So I'm going to get negative 2 over 2 times 0.5. I guess I could have made it half. Hey, what's 2 times 0.5, or what's half of 2? 1, right? So I'm going to x equals negative 2. So that's my axis of symmetry. Let's get the rest of my vertex. I'm going to plug that negative 2 in to each of the x values. So if I plug negative 2 in there, I get negative 2 squared. That's 4. Half of 4 is 2. Plus negative 2 times positive 2 is negative 4. Okay, I should have made that. And then plus 4. So if I add all that up, it looks like negative 4, positive 4, they cancel each other out. So I get negative 2 comma 2. Negative 2 comma 2. Okay, now, critical thinking friends of mine. We normally do 135, but we multiply 135 by the a value. The a value, which is half, or 0.5, right? 0.5, so if I multiply all of those by half, I get half. I get 3 over 2, which is 1.5, and then I get 5 over 2, which is 2.5. Okay, it's still going to graph the same way. So I'm going to go right 1, down half, and these are counted by 2. So see how I just went down just a little bit? And then I'm going to go right 1 and down 3 over 2. So I'm going to go down 1.5. So I'm going to go down 1.5. Oh my gosh.
Doesn't it open up?
It does. Dude. I love you, man. I don't know why I was going down. I got all excited that we had this half. All right. Right 1 up half. So it's down there a little bit. Half. And then I'm going to go right 1 up 1.5. So let's cover the half. That's here and here. And if I go right 1 and up 2.5, bless you, there's 2.5. So that half actually is going to make our parabola a little bit fatter. And in math terms, if we want to be a math geek for a day, if I have a 1/2, it's called a vertical compression of 1, because it's kind of pushing it down in the y direction by a factor of half. That's a little different problem, but I think it's doable. Yeah. 9. Oh yeah, I just want someone to ask for that. All right. 9. Y equals x, and then the 2 minus x, right? X and the 2 minus x. All right, this is in factored form. Agree? Anyone doubt that? Okay, so I'm going to go, this is going to give me x equals 0, and this is going to give me 2 minus x equals 0, which is negative x equals negative 2, so x equals 2. So my roots are are that and that. So 0, 0, and 2, 0. So what's guaranteed to happen halfway in between those two roots? Vertex. So my axis of symmetry falls right here. Okay, so what x value is that? What x value is this? 1. Okay, so that's my axis of symmetry. Let's go ahead and find my vertex, which I know is x comma y. So I'm going to get 1 comma something. Well, I'm going to take that x and plug it right in like I normally would. So that's a 1, and then 2 minus 1 is how much? 1. So 1 times 1 is 1. I get a vertex at 1, 1. Wait a minute, why is this one opening upside down? I mean, this is indeed my thing, and it's going to go right 1 down 1, 2, 3, left 1 down 3. So that is definitely my parabola. But why in the heck did it open down? What's going on that's making it open down? Do you think? Yeah.
Because you found the roots first.
Do what?
Because you found like the roots first.
Okay, but that shouldn't dictate if I.
One's not squared.
What's that? We're not squared. But I want you to think about this. If I were to distribute this here and this here, that's going to give me y equals 2x minus x squared. Let's change the order to put it in descending order. Should that parabola open down? Yeah. So sometimes it might twist your head around going, wait a minute, why is that happening that way? That's a good one. Anything else you want to take a look at? You all right? If you would. Yeah.
Number 8.
8 didn't have to do it.
Oh, we didn't have to do it?
It was just odds. Just odds. Cool. Hey, quick question. You're noticing at the bottom of the pages, I hope, that there's a link that has mostly the odd answers, but it has some of the even ones. Has anyone been going and checking that out? Unfortunately, it's me on there, so didn't get some cool teacher to get on there. All right, if you would, let's make sure our names are on our assignment, please. It has gone forward. Yeah. Oh, shoot. Oh, I might just go ahead and hand forward. I'll make sure. Thanks for checking that. I do goof them sometimes, but I love that y'all are able to see my grade book and make corrections. Back in the olden days, I used to do my grades by hand, so who would know what their grades were? You'd have to wait until every 9 weeks we would mail home a report card of some sort. And that was just bubbled in on what grade you had in class. So you would just see a letter grade. You couldn't see a percent or anything like that, so you didn't know if your B was a 79.9 or was a 89 point whatever somewhere.
A B is considered a 79.9.
Sometimes. If you're a good kid, you got a D.
Me?
Yeah, I'd give you a D.
A D?
Maybe an F.
Thanks.
Yeah, sure. I'm looking out for you. I had a student a long time ago who had failed my class. And I remember the mom came in to meet with me, and the student's sitting right there. And the kid looked right at the mom and goes, yeah, but I got an F. And the alphabet goes through Z, so that's pretty good.
That's hilarious. He was joking, right?
I think he was trying to con his mom, but he might have been halfway serious. Every now and then someone comes through the door. None of you all are really bright kids. Man, every now and then I get some students where you're just going, how'd you find your way back here today? You know,
How did you find your way down the hallway?
yeah. Did your mom just say, go that way? Funny stuff. Goofy stuff. All right. So I don't really have a notes for you today, but I want to kind of just let's review a little bit. And you're more than welcome if you want to write this down on a sheet of paper. You can. If you want to just chill and watch, you're totally fine. It won't be that long, and then I'll let you guys start the assignment. So far we have this. Okay, so far we have this, where ax squared plus bx plus c, that's standard form of a quadratic, and a, b, and c are actual numbers. Agree? So then when we go through this and we ask a few questions. We say, hey, does this open up or down? And that is, what is the a value? If it's positive a, it opens up. If it's negative a, it opens down. Okay, and I'm just trying to review a couple things, because we do have a little gym dandy tomorrow, a quiz. Okay, and so this isn't an actual problem. This is just kind of like a general guideline. What do you think? Is that okay to say that? And then once we've determined it, if it opens up or down, our second thing we do is we find our axis of symmetry, which we will refer to as ALS. And that's always x equals negative b over 2a. So the constants in that part are the negative. Okay, that negative always shows up. Now you could get negative, negative, and that would cancel out, which is fine. And then the 2 is also a constant. It's always part of the problem. Okay? And then the third step is plugging negative b over 2a in. And then you plug it back in to get the rest of your vertex. Now, the vertex is a couple things. So the vertex is either a max or a min. So it's a max when it opens upside down, and you look at the y part of vertex. And then the min is when the parabola opens up, and again, you still look at the y part of vertex. Okay, does that make sense so far? So if you had a parabola that was opening up, and I said, hey, what's the minimum value? And let's say the vertex was 3, 10, you would have to say 10 is the minimum value if it's opening up. Okay, it's just referring to the low point. Okay? And then other things that we had worked on with these, we then go to the pattern graph. Which is a times the 135, and it keeps going. You could go to 7 to 9, things like that. So it's a times whatever those values, and you would count right one or count left one from a point. So you'd start with a vertex and then go either up or down, and then from those new points you still count right or left one, depending upon which side you're on, and then you go up or down the 3 or the factor of 3, and then the 5. And then some other things that take place is we can sometimes see roots. And that's where it touches or crosses the x-axis. The sixth thing is, where does it cross the y-intercept? The nice thing with these is it's always 0, your c value. Okay, that's not the most important point in the world, but it is one more point that does exist. The y-intercept can indeed be where the vertex falls. It doesn't have to be. That takes place. And then a few other things that kind of transpire. Let's say we had where is it increasing? And all it means when it's increasing is where would slope be positive? So let's just kind of make up a parabola here, and let's make up a parabola here like this. Okay, I have one opening up, one opening down. Let's call this x and y. So that's our vertex there. And then I have a vertex right here. And x and y we're just putting in there so they can represent any numbers we want. Okay, so if we want to know where it's increasing, increasing is starting here, heading up. So it's that region right there. So you would have to say on this one, it's increasing from whatever my x value is to infinity. That's where it would be increasing. Okay? It's increasing here on this side. So if I took any of those 2 points to find them, I could verify where it's increasing there. So on this one, it's increasing from negative infinity to our x value. Okay? So that was something that we talked about. But just realize the increasing can take place on either side of the parabola. And it's just a matter of you verifying, hey, is it going up at this point or is it going down? And again, it has to do, it goes all the way up to whatever the x component of the vertex is. That's what we do. We label it in the x direction. Okay? So that's some other terms that we've talked about. We've also talked about where the graph is positive. Okay? Where is it positive? And that means above the x-axis. So let's just draw a couple of situations here. Here. Those are all good representations. So where is this one positive? So it's positive here, and it's positive here. And let's call that the point smiley face, comma 0. And let's call that the point frowny face, comma 0. Smiley face or frowny face represents some number, right? So if I were to say, hey, where's it positive on this one, I'd have to say from negative infinity to smiley face and from frowny face to infinity. That just means that's where it's above the x-axis. Okay? Below it, it's negative. But what about this one? It crosses the x-axis here and here. So let's make this a round smiley face, comma 0. And let's make this a round frowny face, comma 0. So where is this one positive? Where is it above the x-axis? Well, it's in between the two. It's here. So how would I represent that with some parentheses? Where's that above it?
Happy face to frowny face.
Yeah, happy face to frowny face. And again, those could represent numbers. I'm just kind of being goofy because I don't want you to be like, oh, it's always increasing from 2 to 6. I know. What about this last one? It's not. Is it above the x-axis the entire time? Yeah, so look at this. So this whole thing, so that says from negative to positive infinity, it's positive. So those are just a few places that we've explored with these, correct? Okay, the last thing I want to do, and this is just going to help us with tonight's stuff, is let me graph let me do this. Let's say we have y equals x plus 3 and x minus 1. So is this in factored form? Yeah. So if it's in factored form, that'll tell us where it's crossing the x-axis. Okay, so this is going to give me x plus 3 equals 0. So that gives me negative 3 comma 0. Notice it's opposite. And this is going to give me x minus 1 equals 0. So it yields me this point, 1 comma 0. So those are the two places that it'll cross the x-axis. And I can increase this a little bit. Let's see. All right, so I see that I have negative 3, 0 here. And I also have 1, 0 here. So you have to find what's halfway in the middle. Halfway in the middle is the axis of symmetry, AOS, and the vertex. So it looks like, is that 1? Or is it negative 1? Negative 1? So does everyone feel comfortable that that's halfway between positive 1 and negative 3? So if I count over, I got 1, 2. Yep, and I count over 1, 2. It works. So that tells me that, hey, my axis of symmetry is x equals negative 1. My vertex is at negative 1 comma something. What do I do to get the something? Plug it in. So negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Multiply those together so I get negative 4. So I find I had 1, negative 4. I'm down here. And then if I had multiplied this together, I'd get x squared, right? So my pattern graph is going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. Look how well that worked. So that's one way of looking at these. Let's try one more. Let's see. All right, let's say I had y equals negative 2, x plus 3, x minus 1. And they'll be the same things. So is there something different about this one that's sticking out to you? Yeah. Negative 2 out front side. That's going to change the pattern graph. That's also going to change the direction it opens. In your opinion, how is this going to open, up or down? Down. I got that negative out there. Okay. So let's figure out our roots. So we'll get our roots from this first. So this is going to give me x plus 3 equals 0. So that gives me negative 3 comma 0. That's going to give me x minus 1 equals 0. So that's going to give me 1 comma 0. So negative 3 zeros here. 1 zeros here. We've already done this problem for the most part, but I added one little thing to it. And then the axis of symmetry is right in the middle of them. So that's negative 1. So in order to find my vertex, I'm going to plug that in. Plug negative 1 in and get my answer. So negative 1 plus 3 is 2. Negative 1 minus 2 is negative 2. But I have this here as well. Agree? Okay, so let's do the math. Negative 2 times 2 is negative 4. Negative 4 times negative 2 is positive 8. So 1 positive 8. Would this pattern graph as 1, 3, 5, or was it pattern graph with something different? Yeah, that negative 2 out front is going to say, hey, multiply all those by negative 2. So I'm going to get negative 2, negative 6, negative 10. So from my vertex, I can go right one down 2. Oh, that was at 8, wasn't it? I have to move that a little bit. I was off. So -1, 8. That should be about 8 right there. So if I go right one down 2, left one down 2, right one down 6, 2, 3, 4, 5, 6, left one down 6, and then I could go down to 10, but it's off my graph, so. So that's that problem, okay? The axis of symmetry was here. All right, so for tonight, I would like you to do page 67 and 68. You have a lot of time to start working on it, but then we will have a quiz tomorrow, so I will tell you this will be on Schoology. So if you wanted to print it off for yourself, that's fine. So page 67 and page 68. You have the opportunity to start working on that, okay? Good. That should be good.